Got another dual channel handheld scope function generator DMM to take a look at. We're going to put this one through its paces, see how it stacks up to my Fluke, look at a few signals on it. Again, these don't do a very good job looking at complex waveforms, but for simple waveforms, they're good, they're fine, and you can't beat the cost. They are a great bargain for what you pay for them. You're getting a lot of meter. Let's check it out. FPGA MCU ADC hardware architecture with a sampling rate of 50 millisamples per second. 10 megahertz analog bandwidth, built-in high voltage protection module, maximum support and peak voltage of 400 volts. Support for saving and viewing waveforms and screenshots for an analyst. It's got a built-in DDS function generator. It can output 7 types of function signals, maximum output of 2 megahertz for all signals, and a step of 1 megahertz. Or 1 hertz, sorry. Output frequency amplitude and duty cycle are adjustable. And the multimeter has 4-digit 10,000 point true effective value and supports AC/DC voltage and current measurements, as well as capacitance, resistance, diodes, on-off, and other measurements. So let's pop this one open. As you can see, it's still sealed up. The official unboxing. Comes with a manual. Here is the meter itself. This one comes with a little desk stand. That's nice. And some probes, a charge cable, and that would be for the function generator, signal meter, and a couple of scope probes. So let's first of all turn the unit on. It looks like it measures up to 10 amps of direct current or AC current, like directly, no additional hardware required. There's a milliamp port. It says 1 amp maximum fused and a 10 amp max fused input, and then of course your standard 600 1000 volt category 3 and category 4 probes. On the top here, channel 1, channel 2, and the output, and over on this side I'm sure it's just going to have the standard USB for charging. And is there a calibration port on this one? No, there isn't.
Let's apply the probes, turn it on, and we'll do some quick voltage measurements and confirm the accuracy, and then we'll just do some signal measurements and scope measurements. So first things first, our common and test lead. Turn the power on by pressing the power button, and it says the battery needs to be charged. So I guess the first thing I need to do is plug it in and charge it up. So let's do that. Alright, so I don't have a full charge on. Alright, I put it on charge for about 10 minutes, just because I don't have time to sit around and wait for it to charge. So I don't know how much of a charge I got, but I'm sure I've got enough of a charge for doing some testing. So the first thing we're going to do is we're going to turn it on, and I'm not going to read the manual at all because I don't read manuals. We'll do a voltage check. We'll compare it to the Fluke. I've got my power supply. I'll set it to 12.0 volts. There we go, 12 volts. To turn on the meter, I just press the button and it boots up right away, and it's already in oscilloscope mode. So signal generator, multimeter, config, oscilloscope. What's config tell me? Let's go to config and check this out. Well, let's just select the language. Volume is at 50%, auto shutdown. Okay, you can set it up to shut down in 15 minutes, 30 minutes, 1 hour, or off, which is nice. It'll stay turned on. LCD brightness, the default. That's why default, you can have it boot up to how you're going to use it most of the time. So if I go to default and press the, there we go, and save, that should save it. So now if I turn it off and turn it on, it should boot up in multimeter mode, which is the most common mode that I think most people are going to use it in. Of course, you could set it up in whatever mode you want, right? So this was 12 volts that I just put on the power supply. So we connect this here, and it tells me it's 11.96 volts. Now, my fluke might not be accurate, remember, because my power supply says 11.9. What does the fluke say? Oh, the fluke says the same. Okay, let's turn this to 12 again. There we go. 11.99, 12 volts. Close enough. My power supply is getting kind of picky. But as you see, they are measuring about the same voltage. 12.02, 12.03, we're splitting hairs. If I turn the power supply up, 32.1 is what the power supply is set to. It's reading 32.14. So we know that DC measurement is accurate. This is auto ranging, this meter, so I don't have to select what mode it's in. Let's check AC power now. This is coming off my Variac, so I don't know what it is. It's 116 volts apparently. Let's check the fluke and see what the fluke says. So we're within a half a volt. 117.5, 117.0. So we are close enough. Now, because it's an auto range meter, I don't have to switch anything. Like my fluke, for example, I have to switch it to ohms to measure this resistor, which is 470k, or no, 470. This is a 470k resistor, and my fluke is not telling me that, is it? There we go. 477 according to the fluke. Can you read that? Let me stand this up here. Damn lights. 477 on fluke. $476.3. Looks like it's measuring correctly to me. Let's get the next one. This one is 49. And this meter is measuring 52, which it probably is 52 because it's a 10% resistor. 51.8. So let's check low resistance. This is an 8 ohm resistor. Eight ohms. Ah, there we go. That selects volts and ohms manually. That button. You press it again, and it's gone to resistance. It tells you what mode it's in every time you press it. DC voltage, AC voltage, and resistive measurement. And one of these other buttons here should switch us. This one here will switch it to diode, beeper, and capacitor. So in this mode, beep for detection of a dead short, and in diode mode, this is an NPN, so I expect to see about a 0.5 volt drop, which I do. There's that, and the other one, so that's good. And then we'll do the reverse and see that there's nothing on the reverse, and there's no emitter to collector shorts because this transistor is good. So that works. And it actually has indications on here that tells you it's gray, but that's for the manual settings. Capacitor tester, and then diode on and off, and cap. So diode on and off was diode and your continuity test. So it's just two modes. Cap. This one here is volts, DC volts, AC volts, and resistance. Over here we've got temperature in Celsius and Fahrenheit. I don't know what the live does. Oh, you know what? Live would be, that is going to detect if you've got a live wire. So when you're testing, I'll just grab, you use the hot side, and if you're testing for your polarity, you had to go off the isolation transformer because both sides will show as live. Neutral, nothing. That tells you got power. You just use one probe, right? You can also check your ground that way. So that's what live is for. Temperature sensing, there might be an external temperature sensor for this, or it's measuring the ambient temperature. 26 seems to be about what temperature it is in here right now, so it's probably just measuring the internal temperature of the shop. And this one here, amps and milliamps. You need to break the current for that. So if I put this into, I'm going to put it in amps mode just because I think this thing draws more than, well, it might draw only 20 or 30 milliamps. But if we put the plug down, I'm going to plug my fan in, and we'll set this to the 10 amp mode. We'll plug that into 10 amp, and I'm going to basically energize my probes and turn on my fan. Somewhere here I got a button for it. Oh, and that's DC. Let's make sure that we're in AC. AC high current. 389, 390 milliamps. So you got a MA setting, which is fused at 1 amp. That'll measure in milliamps. Or in this case, I'm measuring the high current, which will measure up to 10 amps. So I've got my power flowing through the leads, going through the meter and coming back. So that's current measurement. And that's accurate because we've measured this fan before. We'll test some capacitors now. Just whatever I can find here. This is a 1 microfarad. So I will put the meter into capacitor test, which is that one. It says cap, and throw the meter probes across. I'll short it first just to make sure that there's no charge. There won't be because it's a new cap, but this is a 1 microfarad, and it says it's 1.088, 1.09 microfarads. We can also do the same on the puke meter. Again, the fluke says it's 1.1 microfarads. That looks pretty good to me. We'll try a different size. Let's go to a 47, just because a 47 is what I grabbed. Positive on one and negative on the negative. Takes a second to charge up. It's 42.7. Fluke says it's 42.9. This one's a little low. It's supposed to be a 47. Brand new. 330. Bang on. 330 microfarads. I don't believe it does ESR. I'm pretty sure it doesn't do ESR. I can pretty much guarantee it doesn't do ESR. You want to see it measure a really low value cap? Let's grab a real low value, small one like from a tube radio. This one is a 0.002. We'll look at it on the Fluke first. Fluke says it's 0.002. It's 2.393 nanofarads, which is 0.002. Actually, it's a 0.022, so this is actually measuring it with higher accuracy. This is measuring it at 0.0024, but it's close enough.
It's right there. So accuracy, it's matching the fluke. To go back to auto, just press auto. That'll take it back to auto. Press the menu key to change modes. So if we put it into oscilloscope mode now, we're going to measure a couple different things. Looks like my battery is probably due to be charged up. Wonder if it'll run with it plugged in. Let's see if it'll run with it plugged in. Some will, some won't. I only put 10 minutes of charge, so it might help if I plug the power adapter in for this. See whether it will operate while it's charging. Yeah, it will. So you can plug it in and it'll run off the power. So that's good too if you want to leave it sitting on your bench turned on all the time and you don't want to worry about the battery going dead. You can leave it plugged into a USB power source and it will power the unit. Let's put a scope probe on. We'll take a look at a couple different waveforms. I don't think it's going to do very well looking at video, but we're going to look at video because that's kind of the acid test. Being a digital scope, I don't expect that it's going to show much, but we'll try it and then we'll check the function generator and see how the signals look on the other scope. Comes with two 100 megahertz scope probes, so we're just going to plug one in. I'm only going to use one. I know it's dual channel, but I'm just going to look at one. So let's turn off the second channel, which is, can we turn it on? Yeah, here we are, on, off. Okay, and then select channel 1, and let's see if we can bring this down here. This is adjusting the voltage range. And this should be adjusting, is this the time base? I think this is the time base. Move, does that move it? There we go. I want to move this back down to the baseline. Okay, let's hook this up and take a look at some signals. All right, this is the video signal I'm giving it now. Am I on the right trigger? I'm just going to see here. I'm just kind of going through the menus here. Oscilloscope, yes. Channel 1. It's not locking in on the sync for this. This is color bars that I'm trying to display on here. So complex waveforms, it's not going to cut it. It just doesn't have the bandwidth like all of the other digital scopes, including my Uni-T, which I paid about, I don't know, $500 or $600 for when I bought it a few years ago. They all kind of suck when it comes to looking at complex waveforms. So here it is displaying an audio signal. That interference you see there is from my AM transmitter that's on. Let me turn that off. There, that looks a little better. So we can change our time base by just pressing the left and right keys. And of course, change the gain by the up and down keys. Right now it's on a ×1 probe and it's 20 millivolts per division. Looking at the waveform, again, it performs like all of these digital scopes, DSOs. They all pretty much do the same these days. It's great for basic measurements, but complex waveforms such as video leave a lot to be desired on all of these units. And it's not just this one, it's every digital scope that I've tried. Now, I'm not saying that every digital scope can't measure video waveforms. Some of them certainly can, but not in this type of price range. The ones that can measure complex waveforms, such as video, are ones that are costing thousands of dollars. They just can't do it. They don't sync up, and they don't have the resolution anyway. These should be this is the a color bars that we're looking at. You can see there's the horizontal sync, and that's the burst. But other than that, no, they can't do it. So, but again, for the price, right? You're looking at a price point. If you're going to be looking at complex waveforms such as video, then you're going to have to invest in a more expensive unit. That's basically what it boils down to. Next thing we're going to look at is the function generator, and again I will show this on my other scope so we can take a look at how the waveform looks. So we just hook up the function generator and we'll hit the menu key and switch it to signal generator, and now we can pick our frequency and the type of waveform: sine wave, square wave, triangle wave, half wave, full wave, noise, and straight DC. We'll start out with a sine wave. I fully expect that the waveform is going to look just fine because these units are DSP based. There's not a lot that they can't do these days. They are quite capable. Well, this is something I was not expecting. We have a DC offset. If I put my scope in AC mode, you'll see that everything's centered, right? My baseline is, well, pretty much centered there. Okay. AC coupling. Whoops. AC coupling, everything looks good. There's our 3 volts. DC coupling, it's going from 0 to +3, the output. If I put my meter on and take a look at the DC component, it's showing me 1.48 or 1.5 volts. I don't know whether the other one that I looked at the other day did the same or not. I don't recall whether I was in AC coupling or DC coupling. But definitely this is something to keep in mind, that if you're in a sine wave output, it's the lower peak is 0 and it goes up to +3 volts from there. We'll look at the next, whoops, where are we here? To get back to change your mode, press the pause play button. That will return you back from the frequency setting. And then you can go back over and change the waveform to square wave, triangle wave, half wave, etc. And we will look at those settings. So let's take a look at square wave. As you can see, 3 volts offset from ground to +3. I can change the duty cycle by going into the settings and change the duty cycle. I'll change it to 40%, 30%, 20%, 10%. We can go down as far as 1%. Now we're at 1%. My scope's having trouble locking onto that. I have to adjust the trigger slightly. 14%. We can just increase all the way up from here. So 20%, 30, 40, 50, 60, 70, 80, 90, and go up as high as 99%. We can also go to amplitude and change the voltage output. 1 volt in tenths of volts. So 1 volt, if I go down from here, 0.9, 0.8, 0.7, etc. But resolution is 1/10 of a volt. And this affects the output of all the different signals that can be generated, right up to 3 volts maximum. Actually 3.2. How high can we go? 3.2 volts, 3.3 volts, as high as we can go. The default is 3. Next is the triangular waveform. A half wave waveform. That's what you'd get out of a half wave rectifier. A full wave rectifier would give you that. So you've got a full wave signal. Noise is just that, noise. And then DC is just the voltage, in this case 3 volts. It's a capable unit for sure. I think we're going to tear it down and take a look at how it's built, and then we'll end the video. I don't want it to go on too long. I know some of you like to see the inside of these units to see how they're constructed on one of them, so let's we'll just pop this one apart. I've got a screwdriver that will fit the screws. Nice place for the lithium pack. Good place to stab it when you're trying to pry the thing open. There's the battery on this one. It's a 3000 milliamp hour, 11.1 watt hour, 3.7 volt lithium polymer battery. I think I like the batteries on the other one better. Let's take a look at what they've got in here. Here's the fuses that you can replace for the 1 amp fuse for the milliamp and the 10 amp fuse for the current. The 10 amp current, this is where the plugs plug in. And this one looks to have everything on one side of the board. Whether there's something on the other side or not, I guess if we undo the board, we'll see. Again, they're milling down the numbers on this IC. This is probably an FPGA, or is that the FPGA? This is it has a FPGA, fixed or field programmable gate array, is how this is configured. And I think probably most of them are configured the same way. That way a common design can be used, and they just load different software on it for all the different features that the unit may have. I think that's probably holding it up. There we go. That's what I didn't want to happen. Okay, so there it is. This side's got no components on it other than the display and the pads for the buttons to make contact with. Everything is on the other side, so at least you guys have seen what's here on this unit. Pretty straightforward. A little bit of isolation here between the high voltage and the measurement side. A little bit of a gap there. It's a lot more work to put this one together than it was to take it apart, I'll say that much. I fiddled around with this for several minutes to get the board back in place and get everything lined up. Definitely not designed to be taken apart to this level, that's for sure. I gotta get the board to line up and the connections, the terminals to drop back in the right place. Well, that was an ordeal to get that board back in place. Holy crap, that was a lot more work than I thought it was going to be, and I don't even think it's still in right. Make sure the display is in the right place. Yeah, that was a little more involved to get that common back through the into the hole here because of the way this is designed. We'll just get a close-up of some of the chips on here that we can see. They milled off the chip number. They didn't do it to this one. That's an ARM processor. That's one of the processors. Should be an FPGA in here somewhere too. That might be under here. That chip's going to do the measurement. I'm sure that's the one that's doing the voltage measurements for the DMM. And there is something under here. I'm sure that's probably where the FPGA lives. So let's throw the unit back together, and we will end this one. I'll put the link in the description. This one came from Banggood. Will it turn on? Hey, look, it still works. Good as new. Okay, we'll just check it out. Boots up nice and fast. I'm on the 12-volt power supply. 12.03. It works. All right, thanks for watching. We will catch you in the next one. Bye.